Hey everybody, we're going to do a tutorial on simplifying expressions. This is section 1.1.1 in Unit 1. You can get to this resource either in the packet that we gave you or on our website resource pages. Okay, we're going to get into it right away. You should notice that all of these examples are expressions because they do not have an equal sign. So they're not an equation. You're not going to solve them. You're not going to get m equals a number. We're just going to get another expression, just hopefully with less terms. Remember that terms are these individual pieces of the expression separated by plus and minus signs. That's how we know what the different terms are. We're going to hopefully condense this into like terms and things that we can simplify. Remember your order of operations. Please excuse my dear Aunt Sally, PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction is going to really be our guide to how to get started. Another kind of thing that I could kind of put into your head is to start from the inside and work your way out. So right here in example 1, 4m minus 6 is inside of parentheses. We're going to try to start there. Unfortunately, 4 negative 6 not like terms, so we can't subtract them, we can't add them, we can't combine them. So we're going to have to start working our way out. So immediately waiting for us right outside of the parentheses is this 3. And if you remember your distributive property, 3 jammed up next to parentheses without a symbol means multiplication, and it means multiply every single thing by that number. So you might have had a teacher just with you before where they just kind of went through the process with you, so I'm going to try to do that now. So first things first, 3 times 4m and 3 times negative, that's what the result of this is going to be. 3 times 4m is 12m, and 3 times a negative 6 is negative 18. Remember that subtracting 18 is the same as adding negative 18. Alright, we're going to move everything else down because it hasn't changed at all. Alright, now we're going to look to see if we have any like terms. We've got 12m and we've got 2m. They've got an m, so we can add those together. Positive 12m plus 2m. Again, when we talk about combining like terms, that's adding like terms. 12m plus 2m is 14m. I like to cross out the terms that I've already combined so that I don't keep combining them. It's up to you if you want to do that. Then we've got negative 18 and negative 3. They don't have an m, so they're like terms as well. Negative 18 minus 3 or negative 18 plus negative 3, they're the same thing, and you get negative 21. Now I'm looking at the expression that I've got, cross out the 2 that I've just gotten rid of. Now I'm looking at the expression that I got, still no equal sign, still not trying to get m by itself. Try not to do that because it's not an equation, I'm not solving. I'm just looking to see, are there any more like terms that I could simplify? Is there anything else I can combine? 14m and 21 are not like terms, so I cannot subtract them or add them. So this is where I would finish out my expression, and that's my simplified expression. And I've gone from 3 terms down to 2 terms, which is a good thing. Excuse me. I'll get past example 2. This is the one that you just did, and we're going to move to example 3 now. So here at example 3, we don't have any parentheses, but we do have some exponents. Exponents change our variable. So even though you have x's all throughout each term, x squared is a different variable than x to the third. So you almost want to treat this like it's an x and a y instead of them being the same variable. So we can't combine those. They're not like terms. But the 3x squared and the negative 8x squared are like terms because they both have the exact same variable with the exact same exponent. So we could combine those. Unfortunately, the x to the third and the 5x, they're by themselves and won't be able to be combined. So you could go ahead. There's no order requirement here. I like to start with the highest exponent first, but again, it's up to you. So x to the third doesn't have anything to combine with, so I'm just going to rewrite it. And then working my way down the line, x to the second would be next. So 3x squared minus 8x will give us negative 5x squared. So those will be canceled out. Not necessarily canceled out, but combined. But I crossed them out so I don't keep using them. And then what I'd like to do is just go ahead and bring down this 5x plus 5x because nobody was there to combine with it. So I've gone from 4 terms to 3 terms, and I'm looking to see, do I have any more like terms that I can combine? And unfortunately, because the exponents are all different, none of these can be combined, so this is where I stop, and that's a simplified expression there. All right, example 4, we've got some multiplication. Now, this is different when you're multiplying. There is no requirement for like terms. Just got to be aware of what happens when you multiply. Specifically, these exponents you really have to be careful with. Now, real quick, 3x squared, if I write it completely out and break it down for you, that would be the equivalent of 3x squared. And I'm multiplying that by 4 times x to the 4th, and that would be what 4x to the 4th would look like. So if you notice, I'm multiplying all of these things together. Well, the 3 and the 4, that's not going to be a problem. 3 times 4 is 12. But I'm multiplying all these x's. If you count real quick, 1, 2, 3, 4, 5, 6 x's, that's the same as x to the 6th. So x times itself 6 times is x to the 6th power. So that's the long way of doing this. If you'll just notice, what we did is we took the 2 exponents and we essentially added them together and got what the new exponent would be. 2 plus 4 is 6. That's the other way that you can do this and maybe save yourself a little bit of time. 12x to the 6th is your simplified expression, but keep in mind that when multiplying like bases, that means the big number is the same, that all we have to do is add the 2 exponents together and we will get our new variable. Got a little crazy with this addition symbol here. Let's try that again. All right, so now we'll move to our final example, example 5 here, and we're doing some division. Now, what I like to do is I like to separate this into numbers with the numbers and variables with the variables. So 5 over 3 would be 5. 15 over 3 rather, sorry, not 5 over 3, but 15 over 3 would be 5, because you could just divide those two numbers. They would reduce to 5 over 1. And then you've got x to the 5th over x to the 3rd. And that is going to be a little bit different situation because we are going to have to deal with division of like bases. So what we're looking at is x to the 5th, which is 5x's on the top, and x to the 3rd, which is 3x's on the bottom. And we've talked about in the past in previous math classes that you can cancel tops and bottoms of a fraction that are the exact same. So these two are the same, these two are the same, these two are the same. And that's going to leave us with just the 2 x's on the top, or x squared. Now, how did that just magically happen? Another way of thinking about this is when we were multiplying, we added the exponents. So when we're dividing, we could just subtract the exponents. So that would be the same exact thing as x to the 5th divided by x to the 3rd. And so x to the 5th minus 3 is just x squared. And that's what we got when we did the longhand simplification. So I could just put this into our expression right here. 5x squared on top over 1. Well, 5x squared divided by 1 is just simply 5x squared. Well, thank you for watching our tutorial. I hope this is helpful. There are plenty more on this sheet as well as in your homework.